quality of air in a building are more polluted of the air outside of the building itself. Invented ventilation system is a cool the indoor space in the room. This mixes with the existing stale air and recirculate around the space. In a polluted air quality at breathing level, a better cleaner option is to install a natural ventilation to go to the space. Natural ventilation is a technique of using air movement from outside and go inside of the building. In this cross ventilation, example, the negative pressure defined caused by different pressure of air movement. Natural ventilation relies on air movement through openings such as doors and windows, leaving the space with fresh air, creating a healthy environment for a human, with the same time reducing the building carbon footprints. The case study of the building is a police station located in Frankfurt, Germany, with 1.470 square meter for ground and first floor. Integration of building orientation with natural ventilation is a challenging task as the designers need to study the impact of the wind pattern, wind direction, and orientation of the building exposure area in order to obtain the most optimal ventilation effects. Certain standards have been suggested to optimize the ventilation effect due to the building orientation. The methodology used in this project is a literature review and integrated environmental solution software. Our objective in this project is to improve the indoor air quality based on passive design strategy, improve thermal comfort, reduce the energy consumption, and thus are very limited for CO2 emission and energy saving. Basic principles for the construction of the passive house are passive house windows, thermal insulation, comfort ventilation with high heat recovery, airnesses, and finally the thermal bridge free. A key characteristic of passive house building is a continuous layer of insulation material covering the whole building envelope. This includes wall, roof, floor, and window. A required minimum U value for wall surfaces, it should be 0.15 watt per meter square Kelvin for cool temperature climate, and for the window, the U value of 0.8 watt per meter square Kelvin or less are required for cool temperature, and for the roof, 0.9. The lower U value is better to the building elements are in keeping heat in or out the building. The energy consumption for the base case is 113.554. Velocity is between 0.0 to 0.8 meter per second, and the temperature is between 23.8 to 24.47. The strategy used in these projects are courtyard inside the building, courtyards outside the building, and wind channel. Courtyard is perceived offer a great potential for utilizing natural ventilation and reducing energy consumption of the building. The total energy consumption for the first strategy, which is courtyard inside the building, is 111.457 megawatt per hour, and the velocity for that is between 0.0 to 0.13 meter per second, and the temperature is between 23.28 to 25.18. The second strategy is the courtyard outside the building. The total energy consumption for that is 100.568 megawatt per hour. The third strategy is wind channel through different layout configuration. A number of studies related to building layout design have been carried out in recent years that the building layout had significant effect on outdoor wind environment and ventilation level. The third strategy, the total energy consumption, it was 109.526 megawatt per hour. The velocity is between 0.0 to 0.13 meter per second, and finally the temperature is between 2.2 to 23.28. For the wind channel option number 2, that we have an opening or a wind channel between the ground floor and the first floor, the total energy consumption is 113.28 megawatt per hour. Velocity is between 0.0 to 0.11, and the temperature is between 23.4 to 24.5. As a conclusion, both strategies, which are the courtyard design and the wind channel, impact layout design and natural ventilation, and both of them impact energy consumption as found by Hong and Dean in 2015. However, the enhancement of energy conservation was effective by the courtyard design more than the wind channel, as it reduced energy use, enhanced the thermal comfort inside the building, and improved the airflow pattern.